In this video we have the integral of e to the x over 1 plus e to the x taken to the third power. In some cases it's not clear whether you're going to use a U-substitution, the standard U-substitution, but anytime you can take the derivative of an expression, say in the denominator or the numerator, and you get an expression that's already there, say e to the x dx. And that's a good sign you're going to use the standard U substitution. So in this case, I'm going to let U equal to 1 plus e to the x. And notice if I take the derivative of that, I'm going to get e to the x. So this is going to be du. Derivative of 1 is 0. And the derivative of e to the x is e to the x. And I have my dx there. And notice that's what I have right here. So I can rewrite this as your integral, and e to the x dx, I replace it by du. Now I could solve for dx, and it'll be du over e to the x, and then substitute in there, but it gives me the same thing. So I'm just going to say I'm replacing the product e to the x dx by du. And that's going to be over this expression, but 1 plus e to the x, that's my u. And that's taken to the third power. Now we're ready to integrate. Simple expression here, because if I take the u to the third to the numerator, that becomes u to the negative 3. And let's just follow my power rule for integrals here. Add 1 to the exponent gives me u to the negative 2. And then divide the coefficient 1 by that, so this would be a negative 1/2. Then I got my constant of integration. And then I just go back to the original variable here. This will be negative 1/2. And the u is 1 plus e to the x. And that's to the negative 2 power. And my constant of integration. And that's my answer. And then a quick check on this. If I take the derivative of this expression, I go negative 2 times negative 1/2 is 1. Subtract 1 from the exponent, that gives me a negative 3. And multiply by the derivative chain rule, derivative of 1 plus e to the x, that gives me e to the x. So if I compute the derivative of this expression right here, the derivative of a constant, of course, is 0. So take the derivative of this, it does give me the expression here, the integrand. Thanks for watching. We'll see you next time.